Okay, so let's start. So my name is Slava Tikhonov, and I'm from Royal Netherlands Academy of Arts and Sciences. And today I'm going to tell you something about open science projects and about how to actually to build common data infrastructures and how it can help to create COVID-19 museum. So a little bit about myself. So I participated in more than 10 European and national data infrastructure projects during the last 5 years. And I'm also Time Machine Europe supervisor in my organization. Also, I'm quite active in Research Data Alliance, and I also had some projects with them. And basically, my specialization is data infrastructure, research data infrastructure. Okay, let's switch to next slide. So obviously, we are moving towards open science, and it means that we need large digital infrastructures, we need publication systems, and we need alt metrics. Everything should be open, and it will allow us to speed up open innovation and open all research to the world. And obviously, it's not possible to do without citizen science. And citizen science is the social inclusion of other people that can also contribute to research, and they can bring their own feedback. And this is how we can actually see if researchers do relevant research. So obviously, we are talking about researchers working in a new situation, having some feedback from people that consuming the research, and probably from companies that also interested in research. And it should be moving as a one single piece, as open science, and all data should be shared and should be reusable and should be following common principles. And of course, it should be responsible research, which means that every result of every research should be transparent, and it should be easily reproduced. And also we need public engagement, because it's difficult to build large-scale projects without having people on board and without having social interaction and social feedback. So talking about collaboration in Europe, I immediately go to Time Machine project. So it's biggest international collaboration now in Europe, and it's basically it has a vision to bring 5,000 years of European history to life, and it's about the digitalization of millions of historical documents, paintings, and monuments. And the idea that they want to create largest computer simulation ever developed, which means that after some time, probably after 10 years, you should be able to use virtual reality and go back in time. So basically the idea to collect all information, to collect all historical documents, and give this information, this data to computer, and to create a model of virtual reality. And you should be able to travel back in time for 500 years, for 5,000 years, and you should be able to see all these historical facts that described in documents. So basically, it's a very large consortium with more than 600 members from all European countries, and also top academic and research institutions participating in this initiative. And there are also private companies that are very interested in this development, and there are also gaming companies want to participate and also want to help to create those simulation. So basically, the focus of Time Machine is on big data, artificial intelligence, and augmented reality and 3D. And it just emerging because more people are coming, more institutions are joining, and this is how it goes now. And if you're interested, you can just visit Time Machine website, and I will continue.
Slava, when did the project start?
Okay, so project has quite a long history as well. So first it was Venice Time Machine, and it was created by EPFL from Lausanne, and it was quite a successful project. And what they did, they actually digitized documents, and they created map visualizations. So it was possible to just to go back in time for Venice and to see how it was looking a lot of centuries ago. And after they thought that probably it's a good idea just to invite other people to participate in this and share their developments. And this is how it's basically started as consortium. So I would say from 2015, more or less, this to date. So now there are a lot of different time machines already quite well developed. So you can see Amsterdam time machine also is very active, and there is time machine from Antwerp, Dresden, of course from Paris and Ghent and other time machines. And basically the idea of this consortium just to share all developments and all innovations between all partners. So basically it means that if Amsterdam time machine will create some nice solution to plot a map, historical map, so it can share the same solution, the same tool with other time machines, and they can reuse, and they don't need to spend any time on development. So basically, it's like perfect collaboration. Something that was created in one place goes to community, and other people can reuse, and they can also provide feedback, and initial developers can also use those requirements to develop new functionalities and features. So now I'm coming to the really tough topic. So it's about data management in time machines, because obviously every time machine is building own technology, and it's difficult to imagine that they're compatible, and something that created in Paris can work together with tools that created in Amsterdam or in other cities. So basically in time machine, we're talking about different levels of data management. There is primary data objects like photographs, like images, like videos that should be preserved in digital archives with persistent identifiers. It's called usually called trusted digital repository. And in the same time, there is secondary data that should be stored in research infrastructure with keeping data versioning and provenance information. And this is really important to understand this difference, because if you have something archived, it's just initial object, it's primary data, but this object already has some metadata description and some provenance information. And you really need another repository. You need to put the same data in another repository and create derivative, because researchers will add another layers of information and metadata and another layers of provenance, probably something that they'll find during project. So all this information should be curated, and it should go through all members, and we need to see who is doing what, and how they see object history. It's very important. So basically, after it will go to a secondary source. So secondary means that it will be a research data infrastructure. It should be available as linked open data cloud, and it will provide layer of interoperability. So basically, in this case, if it's the same technology, it doesn't matter if it's in Amsterdam or it's in Paris or in Antwerp. Still, there is interoperability, the same technology, and all data can be shared with different research groups, with different research projects, and they can basically find something new, and they can also get some new insights, probably to find some interesting information for their own research. And this is how it's shared between different partners. So obviously, the reuse of research data should follow so-called FAIR principles. All research data should be findable, accessible, interoperable, and reusable. So I really want
Slava,
yes.
On the previous slide, just for the student, could you give some example of what you have in mind when you say primary data, secondary data, and the other one, the link open data?
Yeah.
Just for you have to understand that the students here are not coming necessarily from computer science or informatics.
Mm-hmm.
They are really broad origins, and it would be good for you to give just example. What is for you one primary data, and what would be a secondary data? Okay,
so let's say you have some artifact and it preserved at Louvre, right? And at Louvre Museum, and after it was digitized, and it was placed in trusted digital repository. So basically, we can only read information about this artifact, about provenance, some metadata, and it's shared with outside world. So to make research project going with such an artifact, you need to put it in another repository, basically in common data infrastructure. And this is where you can give access to all researchers, to all people. Probably if you think about citizen scientists, probably also to people from outside, and they can also make some descriptions, they can make a notation, and they can bring another level of knowledge. So obviously we are talking about secondary data because it's not coming from Louvre. Now it's coming from research projects and from citizen scientists. And this information, because probably you will create descriptions in French, so this information should be also linked to external control vocabularies that will allow to find this if you're searching this in other languages, like in English, right? So this information will be available in linked open data cloud, and people will get like common user interface, and they will use semantic search to find all these new levels of information. Is it clear enough?
Yeah, sure.
Okay, so I will continue then. So what is FAIR? FAIR, I already mentioned, it's findable. So findable means that all metadata is signed globally unique and persistent identifier, and data described with rich metadata, and metadata clearly include identifier of data it describes, and metadata registered or indexed in searchable resource. And another point is accessible, and accessible metadata are retrievable by the identifier using a standardized communications protocol, and protocol is open, free, and universal, and protocols allow identification of authorization where it's necessary. And metadata are accessible even if data is not longer available. And another principle is very important, it's interoperability. So if metadata use a formal, accessible, shared, or broadly applicable language for knowledge representation, so metadata should use vocabularies that follow FAIR principles, and they should include qualified references to other metadata. So basically, if you're talking about language metadata descriptions in French, this is where problem goes. So to make it interoperable, we need to add layer where people can use external control vocabularies and common ontologies, and link the metadata to those ontologies to get a common representation in the knowledge graph. And another principle is reusable. So metadata are highly described with plurality of accurate and relevant attributes, and metadata released with clear and accessible data usage license, because sometimes, it's not open, sometimes should be closed. In some cases, it's even about ethics, that some data is not allowed to share. For example, you can think about Holocaust projects. So metadata also should be associated with detailed provenance. So you should know from where you got this object, and also metadata should meet domain relevant community standards. And our organization is one of leaders in FAIR development, and there is a project called FAIR's FAIR, where we have different FAIR communities collaborating together. I hope it's more or less clear now.
It's clear. Just one question about A2.
Yes.
Data are accessible even when the data itself has disappeared.
Yes.
So it means that you don't ensure the existence of the data itself along the project?
Yeah. So yeah, I can give you a few examples. For example, there are some wars like war in Syria, and I know in Time Machine they digitized some cultural monuments, but unfortunately they got destroyed. So basically, data, the object is not there, and data is not available, probably because you don't have complete data set. but still metadata about this object preserved in data repository.
Okay, so when you speak about metadata, is the numerical metadata from an object?
Yeah.
From real object?
Yeah, from real object. Yeah.
Okay, okay, okay.
So basically, I just covered topic about data, about data infrastructure, and now I will go to data sharing. And so obviously we need to build collaboration between different teams, between different countries even, and how to use best practice for that. So basically we are using Harvard, so-called Harvard Data Commons, and it includes not only data repository that I just described, but also set of research tools connected to this data repository, also computing resources and storage layer. So basically you can see also a research workflow here about collection, cleaning process, and analysis, exploration, and visualization of data. And after it should be curated. So basically it means that every time when you will deposit something, it should create a global persistent identifier, and metadata layer should be very rich, and you should use data dictionaries and vocabularies, and also you should put provenance information from where you got the information, and also it should keep all versions, because in the search project it's really important to see all this evolution of object. Also, it should be supporting access controls, because obviously for some projects you don't want to give access to people outside of your team. So we are also supporting that. So often together, it's just basically working as ecosystem where researcher can do research, and he can share data and metadata with other researchers, probably even outside of own group, and it's available worldwide, so everybody can collaborate. So I'm switching to another point. So it's on this slide, it's another project. It's called Coronavi, and I will explain what Coronavi is in next slides. But actually, if you'll follow these data commons, we can create horizontal platform, and this horizontal platform is our heart, how to say. This is where we can keep all data, we can keep all metadata, and we can just create different teams related to doing something according to their own tasks, and they can just go in parallel. So basically, it doesn't matter how many teams we have. We can just scale it up, because they can work completely independently. Different people from even different countries can join, and they can just work on the common thing without touching other people works. So at this point, I will switch to Dataverse. And what is Dataverse? Dataverse is a platform that we're using a lot in our projects. And basically, it's exactly this horizontal platform. And it's open source data repository that was developed by Harvard University. And it has quite long history. It started in 2006. And they have really good approach and a very flexible, agile development team. Basically, they're welcoming all contributions from other people from community, and this community is already quite big. So currently, a lot of people just considering Dataverse, and a lot of people already joined this community to work together on the same data platform. So basically, our organization now is leading a task in EOSC in the European Open Science Cloud, and we are building this platform for different communities. So including CESDA, which is a consortium of data archives, and Clarin is linguistic community, and Daria is digital humanities. So there are a lot of installations already, and probably this information is already outdated, but currently there are 63 installations worldwide. And I know it's kind of emerging in France as well now, because recently it was discussion about National Open Science Plan in France. And as far as I know, it was decided to use Dataverse as primarily solution for data repositories. And basically, it's emerging in the world, and we are also working on a maturity level of Dataverse to make it really easy to install and maintain. You had some question?
No, it's
Okay.
quite clear yet.
Okay. So what are benefits of having common data infrastructure for different institutions and even for different countries and even for different continents? So because it's distributed and sustainable, it's really suitable for the future. So if you'll invest in this now, it will not die quickly because it's maintained in a lot of places and a lot of people already spending resources on make it live. So basically it means that as more people will join, maintenance costs will drop massively, and you can just dedicate some free money, some free budgets to do training and to do further development or even new research. So it means that reuse of same infrastructure components will enforce quality and speed of knowledge exchange between different organizations and again between different countries. And it will allow to build multidisciplinary and multicultural teams that are using the same infrastructure. And of course, it can bring completely new insights because you can get much more views from different angles in this kind of infrastructure projects. So basically, you can think about common data infrastructure as a kind of gravitational layer. This is where all data science projects will be working, and this is where they'll collaborate together.
Question, Slava.
Yeah.
Do you have some branch of some branch in the development of this tool, or how do you decide the evolution of the tools?
Yeah, so I have I think in
Okay,
next
okay.
slide. Next
Fine,
slide,
it's
I
fine,
have.
it's fine.
Okay, I have this in my presentation. So basically, following these principles, we created Dataverse NL as a collaborative data network, and this is just Dutch network of universities. And currently, we have 15 Dutch universities and research institutions in one Dataverse instance, and every institution has own container and also own administrator. So it means that we are supporting just maintaining technical solution, but they're responsible for their own data, and they're also responsible for curation. So basically, they can decide if something should be changed or some dataset should be closed or even removed. So now I'm really coming to your question. So after Dataverse NL became quite successful platform and people started to use it, we decided to basically to use the same approach and create own Dataverse for every discipline. And currently, we are migrating our data from our archive to different Dataverses. And here you can see on the picture, for example, we have a Dataverse for archaeology, Dataverse for social sciences and for humanities. And there are also other plans to create other data repositories for linguistics, for example, and so on. So basically, how we can renovate services. So every discipline has projects, and we are involved in those projects. And basically, we're collecting requirements from communities, and we are trying to implement those requirements. And basically, all our implementations go back to Harvard. So Harvard, it just basically merging this functionality, this new functionality from us to their own solution. And after it's available for all people on a global scale. So people can start to use our development, for example, in Australia, in Canada, in South Africa, so it doesn't matter. So it's becoming available for open science. So here you can see we have Odyssey project, which is open data infrastructure for social science and economic innovation. And we do a lot of development on statistics and studies and this kind of analysis. And we also have Claria, which is common lab research infrastructure for arts and humanities. And we are adding support of linguistic data here. Also, we are working in European project called SHOC, and SHOC means Social Sciences and Humanities Open Cloud. So in this project, we are developing tools for different research communities. I already mentioned data archives and linguistic communities. And also we are making cloud development. So we're trying to run Dataverse on the cloud. And also we have EOSC synergy, which is basically about maturity of our developments. So basically we want to get all developments automatically built with so-called continuous integration and deployment pipelines, and everything should be automatically tested. It means that people can just use out-of-the-box solutions basically installed in their place without taking care about maintenance. So is it answering your question how we are able to renovate our services?
Yes. You have never some issue with respect to compatibility of new development?
Of course, it's issue, but every time when we develop something new, we are basically inviting people from all people from Dataverse community and also other people from other communities are joining discussion, and we are discussing all issues and we are making proposal. Okay. And at some point we are making agreement that at this point of time it's ready enough and it's compatible, and it could be this functionality, new functionality could be merged to the.
So you are really working like an open source project?
It's just open source. It's even more interesting because sometimes we are in collaboration with other partners developing some interesting functionality for us. So we are also adding some new features for them, and after they are basically maintaining.
Okay. Okay. Makes sense.
Yeah, so basically you can think about Dataverse as our primary platform for open innovation. And what we want to move from closed innovation to open innovation. And you can see this nice table with comparisons, what actually it means. If you think about closed innovation, and obviously commercial companies, they're not able to hire all smart people, and only some smart people can work for them. But in open innovation, it's completely different because smart people working for other partners, for other companies, for other organizations can join open science projects, and we can do development together. We can bring new requirements, and we can basically innovate quickly. And in closed innovation, also profit from R&D. It's more like distributed inside of the company. And in open innovation, if you think about research and development that can create some significant value, it's distributed with all partners and it's shared, and they can also participate and add even new value. So also regarding companies, so companies that will get innovation first, they can win market. But in our business model, well, not business, but our model is completely different because it's basically we just introducing some working solutions, and this is how it goes to the market, and even more people are joining the development. So obviously, we can make best use of internal and external ideas, and we will win against of even big corporations in this case, because all world is working with us. And of course, we partner with universities a lot, so we are creating new knowledge, and we are also encouraging use of this knowledge outside of this field. And we are going abroad, and we are talking to people from different continents, and they're basically joining our developments. So now I'm coming back to FAIR principles, and I just want to mention that Dataverse is very seriously considering also FAIR principles. They want to be compliant, and however, they themselves are saying that FAIR is not really about compliance, but it's about process to innovate on services. So anyway, so Harvard team did evaluation of an assessment of own fairness, and they discovered that discovered that it has really strong support for findable, accessible, and reusable principles. However, there is really weak support for interoperability because all control vocabularies stored internally in the system. So basically, there is no possibility to connect external control vocabularies and use ontologies like Wikidata or other, and that's something that we are going to change in our developments. So talking about interoperability issues in the European Open Science Cloud, you can think about 4 different issues. So first, it's about technical interoperability. It means ability of different information systems basically to communicate and exchange data, and semantic interoperability. I already mentioned all these issues with language, and it's about the ability of computer system to transmit data with an ambiguous and shared meaning. And basically here we are talking about knowledge graph and knowledge discovery and this kind of stuff. Also, there is organizational interoperability. It's basically about policies, how to do things, and legal interoperability, because there is also GDPR law, and of course, we should be compliant, and it's not allowed to share some data sets that, for example, have family names. So we should be also seriously.
I mean, but actually, you are sharing data with the rules of the strongest community. I mean, if one country accepts to share some kind of data and another country don't accept to share this type of data, how does it go?
I understand this issue, and of course, we already faced these kind of problems. Like in Germany, there is slightly different GDPR law than in Netherlands. So basically, it's up to the organization that maintaining and running a data repository to decide about policy.
It means that you cannot have different policies attached to one type of data depending of the country where it is looked.
No. Its policy should be really defined and unique. Yeah.
Okay. Because through a blockchain, you could imagine that you have 2 policies attached to one object.
Yeah, but it could be contradictory also. So
okay, it's in this sense. Okay.
Yeah, it's like for GDPR cases, it's really dangerous, you know.
Okay.
Okay, so I will move on, and I will tell you about interoperability on the global scale, and that's something we are trying to do right now. So we are building fair metadata schemas for European research communities. I already mentioned consortium of European social science data archives. So basically, we have the whole Europe in this consortium, and they're going to run Dataverse as data repository in near future. Also, we are working with Clarin community, which is linguistics, about implementation of component metadata infrastructure. And of course, our idea just to connect metadata and ontologies and use external control vocabularies that will allow to link everything together. So there is also SKOS involved. SKOS is simple knowledge organization, and this is ontology that allows to define the relationship between different metadata fields, between different entities. So basically, we want also to provide multilingual access to control vocabularies, and all contributions that we do, already mentioned a few times, everything should go to Dataverse community and should be merged in source code. So basically, it means that all countries should get updates, and they should start to use this functionality to be compliant with all interoperability issues. So yeah, it's difficult to underestimate the importance of standards and ontologies. So something that happened in the United States, like now there is COVID-19 topic, and there is US National Library of Medicine who is maintaining medical subjects headings, and basically the whole world is using this standard in COVID-19 research. but also very important to have Wikidata, open ontology supported, and other standards. So that's something that we are working on right now, and hopefully after our functionality for external control vocabulary support will be merged. It probably happen in 1 month or 2. So everybody will get the same ground, and this is how we can build. We can start to build a common knowledge graph, and it means that all information can be linked together, and all data can be consumed in all research projects worldwide.
So
yeah,
it's mean that you have created a meta ontology which link all previous ontology together. Then I can imagine that there are some technical issue, because you can have the same object described by 2 different words, but you can also have 1 word describing 2 different objects.
Yes. Yeah, I basically have it in my next slides.
Okay, sorry.
No problem.
Sorry.
No problem. I will explain how it works. So basically, we started to use a so-called SKOSMOS framework, and this is really nice framework for knowledge organization, and different ontologies can be placed here, and you can get kind of index where you can scroll, and you can go through different concepts. So basically, it's very convenient web interface, but also it has API that allows us to connect external applications like Dataverse. And it could be used for different use cases, like publish vocabularies, build discovery systems, and to do vocabulary visualization. And the most interesting thing now is really emerging in France, because I know at least 10 installations of this framework. And for example, INRAE is using this, and they're waiting for our pull request to be merged to get it used with Dataverse. So basically in France, it's already a really good situation, and this is where things basically already started. So now I will just show how it works. There is web interface, it's deposit form of Dataverse. So basically what we implemented, it's really simple external control vocabulary support. You can get a field. So in this case, it's keyword, and you can select vocabulary. Like first is UNESCO, and if you'll type for some term, you will see a list of suggested terms. And after you will select something, it will be automatically filled in vocabulary URL or in term URL. So basically, this is a way how you can connect the same entity to different control vocabularies if you would like to. And the most important thing, after we showed this functionality to our French partners, I believe INRAE, they said that they want also to use language switch, basically to be able to switch to French during metadata deposit process. And we implemented functionality that allows to define language by default. And also, if language switch is enabled, they can switch to French during the process. And after they'll type in term field, they'll search for some concepts, they'll get only concepts in French. But despite of that, it will be linked to the same term URL, which means that if you'll use another languages, it basically doesn't matter. As soon as you have the same URL as a final pointer where you can link all information. Is it clear enough?
Yeah.
Yeah. Okay, so it means that...
just one second. That's okay. This is going from one thesaurus to another thesaurus.
Yeah.
Okay.
Yeah.
The question is, it means that when you are looking for an object, when you are looking using some metadata, you need to specialize with which thesaurus you are looking for this object.
Yeah, that's correct.
It means that in some sense, you need to be a specialized.
Yeah.
And when you have started your talk, your presentation, you said it has to be open for non-specialized. And if you start to make it open to non-specialized, they will not know which thesaurus they are using. They will start to use natural language.
Mm-hmm.
And in natural language, how does it work? It means
Yes. Mm-hmm. I understand.
Natural language, let's take this example with family.
Mm-hmm.
Family can be existing in several thesaurus,
Mm-hmm.
so that it will give different objects. And the question is, how does it work?
Yeah, so basically what we did, we developed this functionality, and we created also some documentation for administrators, so they can allow people to use specific ontologies to describe their metadata. So everything is in control of data repository maintainer.
Okay. Okay, so this is for people who are making metadata. This is not search.
Yeah, so people are limited by basically a repository maintainer,
Okay.
repository owner.
Okay. Thanks.
So now I'm coming to use case, and this is quite a relevant use case for us because it's about COVID-19 expert questions, but also you can think about any research question that can be placed here. So in this example, there is just a database of research questions that was put in SKOS model, and it's available in SKOSMOS, so you can browse through different research questions and you can see some information about them. But in Dataverse web interface, you can now type some questions by keywords, and you can get list of research questions here, and you can basically select some question that you think corresponding to your data. And basically it means that you can put and you can link any research question to your data set, and after it will be available in linked open data cloud. So basically any researcher can find this information in the easy way. And of course, it means that this linked open data cloud will be dynamic. So probably if you'll query tomorrow, you can get even more data sets linked to your research question. So basically, we do understand the complication here that if list of research questions only in, let's say, in English, it's not really useful. So this is why we are working on also on localization framework, actually to provide possibility to translate those questions, for example, in French. So basically the same term URL, but you can get the same question translated in all languages, and this is how you can do your research, and this is how you can annotate some papers that are interesting for you, but they're written in another language. And even more interesting that after we started to do that, we are able to get those research questions as a source for machine learning models. So basically we can create artificial intelligence pipeline that can classify data sets according to what it knows from what researcher already entered and what kind of links we are created. Is it clear enough that you can classify and link research questions to data?
Yes, 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 yes.
Okay, I will move on. So we created service, it's called WebLate, and this is exactly what I'm talking about. In this service, it's also kind of crowdsourcing tool. Yeah? Yeah, it's a kind of crowdsourcing tool where you can also synchronize all translations together. So if you have only English, so you can add French translation or German translation, and doesn't matter. So you can just basically get different reflections of the same entity, and everything should be saved in system, and after it can go back to our services. So this is a way how we can maintain consistency, and we can make this knowledge graph that we are building sustainable, because you can type question in any language and still you can get the same papers linked to this question or the same data sets.
Yeah, yes.
So after, of course, Weblate is not only one thing that we are building. So we are also working on Dataverse App Store, obviously, because we have quite well developed and defined data infrastructure. So we have a lot of applications that we can already connect to this infrastructure. And I'm talking about data previewers. So for example, we have DDI Explorer, which is a tool that allows to browse to DDI studies coded in DDI, and also we have a spreadsheet viewer, we have PDF, text file, HTML, images, video, audio, and geospatial tools connected to Dataverse. And I already mentioned we are working on external control vocabulary support, which means SKOS is also part of SKOSMOS is also part of Dataverse App Store, and also we are working on migration pipelines. And it's quite interesting topic because a lot of institutions worldwide and in France as well, they're running old systems, and now they want to migrate their data to something like Dataverse, and they don't know how because it's quite expensive. So they have to find experts, and they have to do mappings, and this is where we are helping basically. We are creating universal tool that can do this automatically. And I already mentioned a lot linked open data cloud. So we also have a Sparkle endpoint and so-called Fair Data Point. This is in development of one of our projects. And also we are supporting federated authentication. So it means that you can use your account that coming from your institution, you can use for all parts of the infrastructure and also for Dataverse. Also, we are busy with natural language tools integrations, and I will show you how, and visualization tools. So first, I want to show you how spreadsheet previewer looks like. So if you'll deposit some CSV or Excel file in Dataverse, it will give you possibility just to see, like on Google Spreadsheet, you can just see the content of this file without download, which is very convenient. And after we contributed this functionality to Harvard, it's available worldwide for all partners, and people really happy with it because it's kind of visual, it gives visual entrance to data. They don't have to download everything, they can just scroll through different data sets to see where they can find some relevant data for their research.
Mm-hmm.
Another tool, and it's called Clarion Switchboard, and it's about natural language processing. For example, if you have some document, you can deposit in Dataverse, and after you can just run a set of tools, and you can do a lot of interesting things like to do name entity recognition or morphological analysis or lemmatization or morphosyntactic tagger and this kind of stuff. So basically you can run natural language processing tools, and you can get this information also stored back in Dataverse. However, it's not finished yet, and now we are working on this process. So now I'm coming to a really interesting point where we standing now. So we have a very well developed data infrastructure, and it's deployed in and maintained in a lot of countries, and we have a lot of data coming to this infrastructure, and it's available in network. But how actually to standardize everything by hands? It's not feasible and it's not possible because already mentioned we don't have any external control vocabulary support. So basically, we are trying to find solution with using artificial intelligence and machine learning. So it means that we are basically asking experts to create some initial links, and we can use those links to train machine learning models, and we can ask a computer to do this automatically. So there is a coronavirus community who does that, and they also have quite interesting models already developed, and they're really working on natural language processing pipelines that can do that automatically. And there are a lot of people already participating. But of course, it's only part of story. We need proper semantic web support, because obviously, if you'll do name entity recognition, you will get a lot of names, locations, and whatever. But it means nothing without links to let's say geonames or Wikidata or Wikipedia even. So because there is disambiguation, and if you will see some entity like Paris, you don't know if it's a city or it's a family name or it's something else, you know. So it means that historically most of datasets preserved in data silos, archives, and not interlinked, and they're lacking of standardization. And basically what we are trying to do, we're integrating linked data and semantic web technologies with artificial intelligence, and we are forcing research communities to share data and add more interoperability following FAIR principles. And you already know we're going to add external control vocabulary support, which means that we can use what they are producing to train machine learning models, and we can use this information, this data in large-scale projects like time machine, coronavirus, and COVID-19, and doesn't matter in which project. It's just a model that trained, and it can help to do some prediction about automatic linkage of some entities to some control vocabularies. So why it's important? Well, I already mentioned, like for COVID-19, there are not so many experts available. And if you think about the current situation, there are a lot of papers that not getting proper peer review, but getting published. And there is no possibility for human actually to review it properly. And we don't know what is written in those papers. And this is why basically researchers do the same thing a lot of times without knowing that it was already done and the result was negative or positive. So basically what we want to use artificial intelligence, and I already mentioned how. So we are going to build automatic pipelines with some human interaction, and we will apply these pipelines to named entity recognition, data mining, topic classification, and other things. And basically we should be able to build multidisciplinary knowledge graphs that will facilitate development of new projects with, well, let's say, economic and social scientists, but doesn't matter to which scientists. And after we'll see value in this work, of course, they'll want to take ownership of data that artificial intelligence produced. After we'll do review and after we'll accept results. So this is just example. So it's called Spacey. It's a modern NLP framework. And even if you put some text inside, you can get list of named entities that can be filled as metadata and can be stored in data repository. So this is very convenient. So if you have, let's say, historical documents, or you have some newspapers, you can put this text in this pipeline. You can get those entities, and after you can just create descriptive metadata. And here, the only one thing is missing actually is linked to external control vocabularies like geonames, because this is where you can resolve disambiguation. So basically, this is where we are going now with coronavirus.
And you will do this on all the text, or only the abstract, or?
It can be any piece of text. It can recognize now. It's quite well trained model already, and you can also.
I'm convinced that it can be done on any type of text.
Yeah.
It's about the length and the complexity of and the time it will take to analyze the complete text. Is it an issue or not an issue?
No, it's not issue anymore if it's deployed in the cloud. So you can scale it up. Of course, it still takes time to do processing, and results should be refined. But technology is good enough to be used in large-scale projects, I would say. And if you need something more, for example, we are having requests from scientists that working on the classification of professions. So obviously, they want to train their own model. So they're bringing initial data set with all entities, and we can just train model, we can put in this framework, and it should work.
Okay.
So basically, it looks really good already. However, we need to think how to control this artificial intelligence. So I specifically put this image here just to remind that sometimes it could be dangerous also. And it's naive to fully trust machine learning and artificial intelligence. And of course, we need to support human-in-the-loop processes to take control over automatic workflows. Of course, ethics is very important. I already mentioned Holocaust documents. And another problem that you, Eve, already mentioned to me is fake detection, because not all data can be trusted. So obviously we need experts to review what actually we processing. So basically we are working on a solution called Human in the Loop, and there are some tools that already developed in different research projects. And we just need to add, we just need to select best tools, and we need to add continuous integration and deployment pipelines to be able to use those tools on a global scale. And just to give you an example how it looks like, I don't know why it's not coming. Oh, that's weird. Oh yeah, now. So there is a tool that was developed in France. It's called Semantic Web, and basically it's an ontology lookup service. So it means that if you have some data set, let's say spreadsheet, and you're interested to know how to link your columns from your spreadsheet, if you have some variables to which ontologies, it can do prediction to which it can be linked. But after it's just asking questions from human, from expert, if it's really corresponding to what was predicted. And you can say yes and no, and you can basically confirm the choice. And after it will create so-called semantic mappings that will allow to convert everything to RDF. So it's semi-automatic system.
Yep.
And another tools, and now I'm switching to annotation tools. So there is really nice framework called Hypothes.is. It was developed in the United States, and basically it could be used as a peer review service on in the crowdsourcing environment. And basically it has really nice functionality that allows to see, for example, to select some pieces of text and to create human annotations. And the way how we try to use this tool connected to artificial intelligence, we can just highlight all fragments with named entities with some interesting facts that we found, and human annotators should confirm that this is right result corresponding to reality. So if they'll see some fakes, for example, they can also make notation that they think that this is fake and it should be not going into dataset. So this is kind of the way to validate results coming from artificial intelligence. And another tool that is also very interesting, I already mentioned use case where we want to train our own customized machine learning models related to your own research. So there is a tool that was developed in Japan, and it's called Dakana. So basically you can just highlight, you can create a list of entities by yourself. You can also highlight which entity should belong to which class, and it could be used to train machine learning models. So next time artificial intelligence can do exactly the same process automatically, and you can get really nice metadata in your data set. And another thing about visualization. So I mentioned a lot about tools that we already have, and currently we're working with visualization framework called Apache Superset. And this is really nice framework that was originally developed by Airbnb. And after some time, they decided to make it open source. So they just published on GitHub and with open license. And now there are a lot of other companies joined and other organizations, other universities. So basically it's a collaborative effort to develop a common visualization framework. And currently we're busy to connect it to Dataverse. And it means that you should be able to visualize your data on a map in a few clicks. And you can also select like map visualization. You can put information on the charts, and it's very easy to download from Superset image and put in publication. So basically, this is where we are going. And another thing that I should mention, you can also create dynamic dashboard. You can put visualizations you would like to be attached with your data, and after people can just evaluate your results in a visual way, which is very nice and useful for any research. So I already mentioned a lot of things, and basically what we're doing now at Coronavirus community, we already have understanding that all this stuff is open science, is emerging, and it's not only Europe, it's the United States, it's the whole world we have in it. So basically we started to build the integration layer, and we called it BFAIR Open Science Framework, where all of those developments are available, and the idea that they should be we should be able to build them and synchronize with all developments worldwide in an automatic way. So we are building this as a part of infrastructure, and you can see there are a lot of components already available, and it's mentioned here, and it's mostly from European Union, but also, of course, other countries contributing. So basically, there is also a basic infrastructure that I've created for COVID-19 Museum, and it has Dataverse and a couple of other components. And there is also Airflow framework that allows actually to collect data and put in Dataverse in a reliable way. And it's ready to start for COVID-19 Museum after the cloud infrastructure will be available for COVID-19 Museum.
Okay.
So yeah, if you have questions, I'm really open now.
Yep. So is there any question? We have something about 15 participants plus 4 persons here.
No, I don't have questions. May I speak from my seat, or do I have to move?
No, you can speak. The microphone is here.
Okay,
so go ahead.
Hi, Slava.
Hey.
Thank you very much for your talk, which was as clear as possible for someone studying literature as I do. Thank you very much. When you first started talking, you said that you collaborated with private companies. Is Ubisoft a part of them, or do you work with any electronical historical game company?
Yeah, it's of course I was talking about Ubisoft. So in Time Machine they already created really nice simulation, and probably you know about Notre Dame de Paris simulation that basically available online now. And I actually have my own device with their simulations of old cities from Syria. So, and there are other companies also involved in this, of course, not only Ubisoft.
Okay, thank you very much.
You're welcome.
Is there any other question from the students or everywhere? Come on, don't be shy. I know it was a surprising subject, but okay, I have one question, Slava. Let's imagine I want to, first of all, I want to understand one thing. Is there a way to ensure computation inside the project, or do you have to download the data on which you would like to work to make some computation?
Okay, so yeah, this is really important question. So basically, Dataverse is a part of API economy. So it means that it's not really necessary to download object and to do processing on your computer. So you can do it in virtual research environment that deployed somewhere in the cloud or on some server. And after you can get the result of processing, and you can deposit it back in data repository in Dataverse.
That's okay.
Basically, everything can be done transparently, and you will just get notification after it will be finished.
Okay, so it means you have a kind of computing resource which are shared somewhere using a kind of SETI at home or folding at home, or?
No, it can be any kind of service, and there are a lot of services connected to Dataverse. Well, there is research space project that can consume data from Dataverse. There are a lot of other integrations. And probably I will just put a list of integrations in the chat because it's quite long list already.
And my second question is about reproducible research.
Mm-hmm.
And with reproducible research, I need to be able to build the same list of documents I have consult or I have a request the first time. So it's mean, how do you ensure this? Because when you was building request, it was not clear that the document was, the list of the documents you get was reproducible.
Reproducibility, of course, it's quite a tough topic. So we are somewhere in the middle of the road with reproducibility, and basically it's not so simple also to keep provenance for all involved actors. So,
yes, this is an issue that I am considering, which is really something very hard to think about.
Yeah, so you can think about, let's say, so dataset drift. If dataset is developed in time, so there are different versions of the same dataset. It's like first thing. Also, software is changing in time, so you have to keep the track of all versions of software, because obviously you can get different results in the end. So in the ideal case, you can archive software in this software heritage archive, which is basically in France, in Paris, and you can get access to versions, and you can also use those versions after some time. So everything should be basically tracked and should be stored as provenance information in Dataverse to be able to run reproducible research.
Okay. Yes, Juliette?
I have another question about ontologies. Is there someone, or is there even a group in Time Machine Europe working on the cultural and ethical meanings, connotations of the words used in the ontologies? For example, I read from one of the slides the word race, which has quite a different meaning in the European countries and in the USA.
Yeah, of course. I know it was discussed a lot, and there is no agreement how they're going to cover these kind of issues because there are different views on the same events, on the same topic, and it should be kind of agreement between scientists. So there are a few groups active in Time Machine, but well, as far as I know, there is no common agreement yet. It's really, it's in a way, it's also a very sensitive topic if you think about wars or about some events, and people have completely different, could have completely different views on some events.
Sure. Sure.
I have one question. Just coming back on the topic of translations and review, getting the same data set when I doing some research. That's us, like I'm willing to do a systematic research review, right? So I put some rationales in the research, in the first to get the papers. And then there's a variable that you talk about, which is actually very good. It's the translations for some topics, because if I search it in French, I'm expecting I will probably get also some English topics, right? Is it a way to nevertheless ease the reproductivities of the search so that I can get the same result? I mean, Eve already talked about that, but is it the translation making it more complicated to get the same result afterwards?
Well, again, reproducibility is very difficult topic, and it's not only about translation itself. You can also think about like concept drift, it's called. So something that changing meaning in through time, you know. So it doesn't necessarily mean that if you have some translation that was done 10 years ago or 100 years ago, it's corresponding to the meaning that you think right now. So it's only how human it's only human can make judgment about that. It's not possible to do it automatically.
Jacques, ça vous satisfait comme réponse?
In
English. Sorry.
Not really. I mean, it's partly okay. It's really challenging when you would like to do this kind of systematic literature review to not get the same result, right? Because then the whole is in questions. Especially if you want it to be published, then you have already a very huge barrier to provide accuracy of your search. So yeah, it's probably something that need to be further checked, right?
Yeah, it's for I already mentioned. So we have a lot of human in the loop tools that could be useful. So basically, if you have experts in house, you can give them those tools, and this is how you can make you can increase quality of research. But there is no way to do it automatically, and these translations, well, people can also depending from who is translating what, it can be also different, you know.
Okay.
Yeah.
Thank you.
Jacques, you have to understand that the translation is just one tool that you are using inside the process. So you have the automatic process that you will have to set up and that you will have to store. It means you store really how you process the data. And then you have the data before. So you have to store the data, or at least the list of the data you have access to. And then you have to store the process you will put on the data.
Mm-hmm.
And what is reasonable is also to store the result of the process. Because this is an issue, is not to be able to check whether or not you get the same result using the same tools on the same data, but 10 years after.
Stand in front of the image, please.
Oh, sorry, I'm not in front of the image. Yeah. So this is a real issue, and it's something which Slava said they are thinking about, but it's not really already prepared completely, if I have well understood.
No, it's not prepared, and especially now because all these artificial intelligence solutions basically emerging, it's out of the control.
Yeah.
You don't know, it's a black box. How to track what it's produced.
Yeah, it's a black box, and the only thing is that you should be able to say, okay, I have used this black box in version blah, 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 and store all this process. And Jacques, this is in some sense done on this virtual machine that you stored when you have some data to analyze. You store the virtual machine which has processed the data. So you don't store the data inside the virtual machine. You store the state of the virtual machine, which has processed the data.
Yeah, and currently we also have a working group in Dataverse community. So basically we are discussing how to create, how to archive complete images, how to store those images and create preservation layer. So people after 10 or 20 or 100 years should be able to reproduce results of research projects.
Yeah, Juliette?
If I understood well, you told us that Time Machine Europe is going to collect all documents available about historical events in Europe. What about literature? For example, will you consider Shakespeare's Macbeth or Richard III as an historical document?
Yeah, it's a good question. I think they want to do this, but still, I don't know if someone already does that. I don't know.
Yeah. This would be a Dataverse inside a library, for example, if I well understood. It could be,
probably.
Yeah. Is there other question from anyone in the room?
Peut-être on peut suggérer de poser des questions en français et de traduire si c'est pas.
Ah oui, si quelqu'un veut poser une question en français, il n'y a aucun problème, on peut traduire. Hein. En plus, Slava parle français. Donc.
Yeah, you can try in French.
Chinese, perhaps not, but Slovene. Non, pas d'autres questions?
I wanted to say that it's very, very interesting because we are in the context of a digital museum, right? So when you go in the normal museum, you expect to see the same piece. And when the time is going on, come back 10 years after you have the same piece because it has been well protected and so on. So so it's very interesting to see that it's kind of the same process that you try to build data on the backstage. I hope that it will be very successful because that is the whole idea of the COVID museum, obviously, that we get the same thing when the time passed. And then we can use it or other generation use it the way we used some times ago. So yeah, we hope that you will come with an update that will be helpful, at least for those that are not technicians like us, to work with.
Yeah, but I would say COVID-19 museum is already around us. So if you think about videos with empty streets, everything is already published and available on YouTube, for example. You can find a lot of photographs published somewhere in different sources. And basically, this is where primary data is already preserved, right?
Yeah.
And the Dataverse, I already mentioned a lot of times, it's a secondary data source. This is where you can get links to original objects. And those links should be should have metadata descriptions and should be connected and linked to ontologies and control vocabularies. And this is how you can make this information findable and linked. And it should be also searchable through semantic search, which means that if you'll search in Spanish or French, you should be able to find this. Doesn't matter which kind of description it will be. Or if it's available in knowledge graph, you can also query some Sparkle endpoints, like technical solutions that could provide you data about what is already stored there. So it's all feasible, and it's basically exactly the same concept as Time Machine Europe has.
Okay, thanks. So it's now here 11:21. I propose that we take a 14 minutes break and we come back at 11:35, if it's okay for everyone. So 14 minutes break, and then Anne will speak about the same thing in some sense, but probably more the idea which are behind this.